Okay, cool. Well, thank you so much for having me here, and thanks to all the organizers for organizing this, and also the attendees. So my name is Ray. I'm a developer advocate for Google Cloud Platform, and I love Java. I'm a Java champion as well. But I also like a lot of the architecture and also deployment in production systems. And so I am also very involved with the Kubernetes ecosystem as well. If you have any questions about this session, please ping me on Twitter, which is @Satanism. Okay. Since we only have about 30 minutes, I'm going to move relatively quickly. And in the end, I'm going to share some more information on other links too. But this photo though is very special for me. So aside from technology, I love to travel. Given the current situation, I cannot go anywhere. So I do miss the traveling. But when I'm traveling, I also take a lot of photos. And this photo is very special to me. I was a backpacker many years ago. I was backpacking for about 4 months. And I came across this city in China where they didn't really have cheap places for backpackers to stay. They only had expensive hotels. And so as a backpacker, I had to ask around, like, what do I do in this case? And two different people told me independently that if you take a bus out somewhere, like a few hours out, and then transfer to a car, they will take you to an entrance of a desert. And if you walk in the desert for 4 hours in southwest direction, then you're going to find this oasis, and then you can stay there for free. Okay. And I heard the word free, and I asked, which bus do I take? Okay, as a backpacker, danger was not in my mind. It's just about free. Okay. So I don't know if anyone here hiked in the desert before, but this is what it feels like. The sand is really soft. And when somebody tells you that go southwest for 4 hours in the desert, you can see that we have all these sand dunes. It doesn't matter what's in front of you. You go in that one direction. Okay. And so you're going up and down, and you're going to pull your legs out from the sand and take the next step up and down these sand dunes with a heavy pack with water. And it was treacherous. It was hard. It was difficult. It reminded me of work as a Java developer writing J2EE application, and here I thought I was on vacation. However, the end was absolutely beautiful. This is the actual photo from that oasis. Obviously, I survived, so I found the oasis, and it's beautiful. And as an engineer, this is what I like to get to for my applications as well. I want to get my application to production. And the road to production is not always easy. Sometimes we meet these obstacles, and we have to solve them along the way. And I see my job as hopefully being able to help you through this journey so that you don't have a bad time. Okay, so as easy as possible. And that's what I'm going to show you today. Just a few things I learned as I help an internal project to go into production. And there are many things that we need to check against to make sure that we are ready for production system. Okay. And first thing is that local development is not production. Okay, so what I'm going to talk about today is what developers can do on the local development side for my application so that my application is ready for production. However, it will be almost impossible to bring that production environment down to my local environment because production is just so hard. There's just so many more things to consider, so many more things to run. And if you make your local development production, you might as well just develop against production anyways, right? But in local development, what I want to focus on is just the developer productivity, and what engineers should be focusing on is the design of your application. And we need to start off by just understanding that, on the left-hand side is development, on the right-hand side is the full production environment. And there are so many things that's different. So how can we actually bridge these two gaps? Well, we need to understand the contracts between your application and the tool or the platform that's orchestrating your application. Okay. And once we understand these contracts, we can go back and make sure that we conform to these contracts. And now we will have a much easier time when we go into a production environment that has a lot more, considerations that's being built in. But as long as you adhere to these contracts, you're going to have an easier time as you move upwards to your environment. And this has to do with application lifecycle, configuration, metrics, log collection, and how your container image is constructed. So I'm going to go into some of these in more detail. But first, remember, this all starts from your application. It has nothing to do with Kubernetes. In fact, if you recall, years ago, 5 years, 10 years ago, we didn't have Kubernetes, but your application still runs somewhere, and you still have to follow these design principles. Tomorrow, there may or may not be Kubernetes, in which case, you still have to make sure your application is properly designed. And one of the most known patterns right now and most popular is 12-factor app. I'm still constantly surprised by how many people who haven't heard about this. I hope everyone now understands this and have heard about it. And in 12-factor apps, there are actually 12 different things that you should look for and implement and design for your application. And everyone here, even if you never heard about it, you should at least have one factor, because the first factor is checking your code. It is 2020. Everyone should be checking in our code. And this is just one of the factors, right? Everyone should have no excuse not checking their code. But many of these factors really, really also help with being able to deploy this application into Kubernetes too, right? This is completely just about your app, but it just so happens it's also very useful for Kubernetes deployment. So for example, being able to externalize your configuration so that you don't bake in the config or any of the secrets into your app, into your container image. That is super, super important. Or that you are able to scale out your process via the process model, and that your processes are stateless, right? All of these are just basic design principles that happens to be really, really useful. So number one, so make sure you follow and study some of these factors and implement as much as you can. The second of this is that, again, this is all about your application. You should be able to test your application locally, okay? And what I mean by that is that you should not depend on a lot of the external stuff in order to run your test. Even if you are developing against Kubernetes, you should still be able to test your application repeatedly and consistently, even just from your local environment. And but you might be asking, well, wait a second, but sometimes I depend on another service. Sometimes I depend on another database where I do need to test against a real database. How do I bring those things up? Well, first of all, for services, you should actually have mocks, right? So make sure you have mock services that you can just bring into your application so you can do that mock tests. If you do need to use any external components, like for example, you're using PostgreSQL database or you're using MySQL database, you want to test against those databases, then another tool that's really, really powerful, especially for Java application, is called test containers. And test containers can work also for other languages too. But then let me just show you what this looks like in a typical Java-based unit testing, right? So in my unit test here, I'm going to test against a repository that has CRUD operations to my database. But rather than connecting to a shared dev database or a QA database, what I'm going to do is to use test containers to ephemerally spin up a container that has my mock data with my username and password that's completely used for testing. And I can even use any Postgres images here that you might actually want to use in your production environment. Of course, this is not a production database, but it's pretty close in terms of version, right? And now you can simulate a lot of the things, and then you can use this container metadata to configure your own application to connect to it. And so if I were to run this unit test right now, everything is self-contained. It does use Docker behind the scenes, but as I run this unit test, when the unit test starts, it's going to start up the container for me, bootstrap my Postgres database, for example. You can start off other containers too, and then make sure my application is connected to that database with the right credentials, and now I can run my test. And then I can do this repeatedly and consistently because I'm not depending on any external data that could be modified by somebody else. So this is super important. Make sure you can run your tests locally and it's reproducible, okay? And fix any flaky tests. Anything that's flaky, that is not good. This is just a basic design principles, right? However, for the application lifecycle within Kubernetes, this is something that you do need to think about. So make sure that your application has the proper lifecycle hooks. And there are a few things there. Number one is, how will Kubernetes know that your application is live? And this is what we call the liveness probe. It should be a simple probe that checks against your application that simply tells Kubernetes, is your application alive? And if it is not alive, it's in trouble, fail this liveness probe so that Kubernetes can automatically restart your application. Okay, so this is the contract that you will have with Kubernetes. And the second part of it is the readiness probe. The readiness probe is a little bit different from the liveness probe. Okay, so if liveness probe fails, then Kubernetes will restart your application, thinking that your application will automatically recover if you just simply restart it. Okay, for the readiness probe, this is the probe that you will use if your application is ready to serve. But you might be saying, wait a second, my application is alive, so it's ready to serve, right? In some cases, yes. But in many of the larger enterprise applications, that may not be the case. Why? Because your application could be alive, but it needs to do some other initialization, like preload some data, preload some stuff into the cache, make sure all the connections are established, right? To get into that ready state so that you are actually ready to serve the very first request. If you don't have this, then Kubernetes will send a request to your application, and you might still be loading this cache data from the database, so that your first request will be really slow, potentially, right? So you can use this kind of contract to tell Kubernetes when to start serving traffic. As soon as you turn this on, then Kubernetes will then enlist your application instance into the load balancer and then sending the request over. Okay, I'm going to show a demo of this later as we go into Kubernetes itself. But this is from your application perspective. You need to have liveness probe and readiness probe that can be configured later. And then your application should also have some kind of contract in terms of how to shut down gracefully. Okay, so for example, if you're writing an online transaction application and you have all these in-flight transactions that's coming in, and when Kubernetes want to shut you down because you're scaling in or that your application is having trouble, is trying to restart you, then it's going to send you a SIG-term signal. And you should be able to respond to this signal and say, hey, Kubernetes is trying to shut me down, and so let me go ahead and clean up. What that means is that you need to finish all the in-flight transactions. You need to have any of the background processes, thread pools to be shut down and make sure that all of those work is complete. And potentially, if you don't want to receive any new traffic, you will then fail the readiness probe, right? So if you turn that off, then Kubernetes will then stop sending traffic to you. But you do have all of these incoming connections that's already established. So these are in-flight connections, in-flight transactions. You need to make sure that you finish serving those requests as well. And then you shut down gracefully when you're ready. If you don't shut down gracefully, there are some configurations that you can configure in Kubernetes that will then forcefully shut you down. So in that case, rather than a SIG term, what you're going to get is a SIG kill, and that will just shut your application down. And this is configured through something called the graceful period, right? So by default, the grace period is about 30 seconds, if I could recall correctly. So if your application doesn't shut down in 30 seconds, it will just forcefully kill it. And then you are at risk of potentially losing some in-flight transactions. On the other hand, you can also increase this graceful period to a number that is proper for your application. So these are the things that you need to be checking against. Okay, so Lifecycle hook with the liveness probe and readiness probe, and being able to gracefully shut down as well, and receiving those signals. Another thing that you need to check is just don't write to the file system. If you are writing an application that is meant to be ephemeral, like stateless, and scale out and scale in automatically, and also running as a container, definitely please do not write to the file system. In most cases, that's not necessary. And the reason I bring this up is because many of the more traditional applications, we tend to write logs to the file system. Those are not the best practices in Kubernetes. What you should be doing is to just string the logs to std out, and usually the Kubernetes installation, like on Google Cloud, we will ingest whatever that you send to std out, and we will send those things directly to a centralized logger. So there's no need to write to the log file. Another problem is that in a traditional VM, the log files are automatically rotated. What that means is that you may be writing the log file, but then only to certain amount, certain sizes, and then it gets garbage collected because there is log rotator behind the scenes. In containers, those rotators may not exist, and so your log file can accumulate. And definitely do not write data either, because your data is going to be stored in the container file system, which are going to be ephemeral. So the next time you start your container, all the data will be gone. So just remember, don't write to the file system. The easiest way to make this check is to just make your file system read-only. And once you do that, you're going to see all these issues popping up. And now you can get rid of those things that's writing to the file system. Okay. So just to recap some of the consideration for the application: two-factor app, repeatable local test, respecting the application lifecycle hooks, having the health checks, and the graceful shutdown. Now, two other things that's really important: externalizable configuration. That is really just part of this 12-factor app. You do not want to store any credentials in your container image or inside of your application. And the final bit of it is the metrics, right? How is your application going to relay the metrics information, like QPS, latency information, or any of the other application-specific SLO? So you need to define that strategy somehow. Most of the people writing these applications in targeting Kubernetes, the metrics are usually collected by Prometheus. So make sure that your application exposes the metrics via Prometheus endpoint. and if you're using Prometheus. Otherwise, whatever metrics vendor that you use, make sure that those things are in there too. Right? Now, then once you have your application designed properly, respecting the contracts, then we can move into containers. Now, this is actually the most difficult part. However, there's good news. There's an easier way to do it. But this is what I usually see, for example, for a Java developer to build their Docker file. Okay, so they say from OpenJDK, copy the source, do the build inside Docker for some reason, and then copy out the final build artifact, which is in this case a jar file. And then I have seen this in many Docker file. They try to copy in some credentials like a service account or some token that they need into this container image. And then finally, they run a java-jar app.jar, right? And they ship it to production, and that is really, really bad. We really need to have some more discipline in terms of understanding and writing these Docker files. And if possible, don't write them at all. Okay, so let's see what's wrong with this Docker file. Well, first of all, on the top, which JDK version am I going to be using? Without specifying it, it's going to use the latest version of the OpenJDK. Same thing for any other runtime like Node or Go or whatever. And this is bad too, because you always need to know what version of the runtime you're trying to use. Especially for OpenJDK, for Java applications, the wrong JDK versions may cause you a lot of pain because they are not container aware. They actually do not understand how much resource you can use in the container. So you always want to know which version you're trying to use and try to use the newest one, obviously. And then the second part of it is that the source file ends up in the container. I have seen this before. If anyone gets into your container for whatever reason, however they get into it, they're going to see your source code. That's bad. And then if you're building in this way, then the packages and anything that you download the intermediary when you're building this container will also stay in the container. They didn't go away. And then the jar file itself is really, really big. So it could be 80, 100 megabytes large. And this is not really optimized for container either. And finally, obviously, the secrets or configuration, they should all be externalized. You do not want them to be in the container that you put into a container registry, right? And finally, the most important part is who is the user running this? Overwhelmingly, all of these base images are going to be running your application as root. And in the production environment, that's not the best idea. Even in containers, you do not want to run your application as root, and nobody really checks against these things. So these are just a few things you really need to check against, right? So here is a little optimized version of this. It's not the best version of it, but still somewhat optimized. So rather than building in the same container image, in this case, we're using multi-stage build so that the build artifact is in a separate container layer that will never show up in your production container, okay? And the second thing is that we specify the runtime environment with the tag. So in this case, I really want to use Java 8, update 242, that is container aware. And I'm also picking and choosing whether I want to use a JRE, which is a Java runtime environment, or the JDK, right? If I'm running my application, a Java application, I just need a runtime environment. I don't need to do compilation, so I don't need to do JDK, right? And that's going to reduce the size of your container image. And then don't run this as root, so you specify the user, right? And then and you optimize other things. And this will get you to a much better place. However, a friend of mine, Matt Rabel, who works at Okta, is a security company that writes authentication and SSO. And he famously says, friends don't let friends write authentication. Why? Because authentication is tedious, it's repetitive, and it's easy to get wrong. I'm going to steal that and say, friends don't let friends write Docker files. Why? Because the Docker files are also very easy to make mistakes, and it's also really easy to make wrong, and also it's really repetitive, right? So when possible, use another tool that can automate these things and then automatically implement the best practices. So there are two projects out there like Jib that you can use with Java, or you can use something like a cloud native build pack. In both cases, they are going to be able to analyze your application and then feed you through their own pipeline, which is already codified with best practices. And it will automatically analyze your application, and out comes the container. So you can build your application containers without any Docker file at all. So for example, I'm going to go here to my, in this case, a Java application. If I want to use Jib to build my application, all I need to do is to add a little plugin. And I just need to go to my command line, in this case, and say event git build, and I do not need a Docker file at all. And this will automatically analyze and create the container for me with most of the best practices. And I need to specify the registry, for example. Let me just do that, and we can build this again. Okay, super easy and much better than having to write Docker file over and over again. Okay. Now for containers, here's the little quick checklist. Just make sure that you know what's in the container image. I have opened up container images before that somebody else produced, and there was source code in there, especially for compiled languages. That's not necessary. There are lots of these intermediate build artifacts like Maven. The entire Maven central is in there, which is not necessary potentially, right? Or sometimes there are Git directories in there. I don't know how they even got in there, but when you say copy everything in there, I guess you get the Git directories. So be careful with this. Always double check. And then you want to optimize a little bit more and just make sure you don't run as root. And especially if you're using Java, make sure it's container aware and use tools whenever possible. Okay. Now, finally, to Kubernetes. Once you have the container in your application, here's going to be the easier part. Now you can use Kubernetes to use the contracts that you have just adhered to. So for example, I'm going to open up a Kubernetes file here. There are a couple of things that you must do. Number one is this container image. In production environment, always version your container image with a tag. So rather than running latest, always do like v1 or you have your own version scheme. So make sure you always tag your image with the container tag here. And always externalize your configuration using invar, config map, or secrets. And here are the two very important things. One is called resource. Okay, so resource is how much CPU and memory your application can use. This is super important. Why? If you don't specify it, then your application is going to think that it owns the whole machine. Okay, so if your machine has 16 gigabytes of RAM, your application will think that you can use all 16 gigabytes of RAM. But in Kubernetes, we will be bundling or bin packing multiple application instances into a single host. So if every single one of them thinks you can use 16 gigabytes of RAM, then you're going to run into out of memory issue very quickly. Okay, so in this case, what you want to set are two things. One is the request. So this is the minimum amount of memory and CPU that your application needs. So this will be used to make sure that, hey, I'm going to schedule you to a host that at least have this much memory and CPU available. Okay, but you also want to set a limit. This is how much you can use at maximum. So this is how much you can burst to. So even though I give you one CPU allocation at the beginning, but now you can actually use as much as 2 CPUs when you need to. Okay, similarly with memory. Now, one thing to watch out for here is that for the memory, if you exceed the memory, we will kill or try to shut down your application because memory is not compressible. So if you exceed the memory limit, we'll shut you down, going through the SIG-term signal. But if you do exceed the CPU allocation, we'll just throttle your application, so you'll just become slower. Okay, and then you need to remember the liveness probe and the readiness probe that you created earlier. You need to configure those with Kubernetes as well. So for example, liveness probe, I need to use it via HTTP GET so I can hit the endpoint. And readiness probe, I do the same thing. However, this is the most important thing you have to really think about. Every application may be different, which is an initial delay seconds, which is when will the liveness probe start to check, and how many times will count as a failure, and how often do we actually check. Okay, so if your application takes 10 minutes to start, true story, it could happen, or even 5 minutes to start, then your initial delay second has to be reconfigured. 0 will be too short, 10 seconds will be too short. If your application takes 5 minutes to start, maybe you check after 5 minutes, right? So that will be 200 seconds. And then because otherwise, if the liveness probe kicks in too early, and within the first 30 seconds, it failed 3 times, but your application is still starting, you will go into this infinite loop of restarting. It will never start. And you definitely have to watch out for it. I have seen application go into this infinite failure loop, restart loops, just because it starts too slowly, and this configuration hasn't been configured with. Okay, and then you always want to check in the YAML file. This is the final bit I'm gonna talk about. All the YAML files that you create for Kubernetes, always check them in somewhere. I cannot stress this enough. This is going to save you if you accidentally wiped out some environment. Then you can recreate this environment very, very quickly with the same YAML files that you used before, because you checked it in. Now you can just do kubectl apply, and then you can get the same environment up and running in no time. Okay, so I think that's almost the time that I have, with a couple minutes for questions. So I'm gonna go to the last slide here, which is just learn more. Obviously, 30 minutes is really short, but if you want to learn more with the more advanced topics, here are some of the links you can try with recorded talks and even collabs. Okay, cool.
Awesome, Ray. Thank you very much. So I do have one question. So when it comes to using the Jib tool, so like that makes sense. It's like I'm definitely not an expert when it comes to putting together Docker files. So kind of unloading that off to like some sort of tool that introduces best practices and all that into it is good. But what can you do to kind of make sure that like something suddenly doesn't change in your Docker file, and then all of a sudden something that was working before is all of a sudden breaking and you don't know why? Like, can you kind of set like, I want this specific version of Java or something like that? What are some of the configurations you can do with that?
Yep. So if you're using a Docker file, then where you set this base version of Java or the base image goes into the from block. If you're using Jib, for example, we also have configuration here. So I can say from image, and then I can say OpenJDK, for example, AU 242 GRE slim, right? And this way, whenever this image is being built, you will use this same base image over and over again, and that will give you the consistency.
Okay, great. Yeah, and I guess there's probably, I'm guessing, just like a lot of options when it comes to this configuration to make sure, anything that you need, you can pass in there as if you're writing your own Docker file, but you don't actually have to specify all that stuff if you don't need to.
That's right. Yeah, and similarly here, I do need to call out like what user do I want to run this application as. Even with Jib, you need to call this out because also by default, it's going to use what's default in this base image, and every base image may have a different user and group that you may need to use. So you do need to configure this as well.
Nice. This is really useful, particularly the Jib tool. Becoming a bit more familiar. Just before you, Paul Sarkowski, kind of mentioned it, but now, a very good, I guess you could say, layup in that he mentioned it. Now you kind of went further in depth into it. So I'll probably actually have to consider using that in some of my tools or some of my tests. One question I do also have is, like, I really love test containers. Have you done anything when it comes to like how to share like data volumes or something for like a database or any of like that maybe back end data you maybe want to have for your test, or have you just also kind of mostly just tooled around with it as well?
So for the test data, depends on the framework that you use, right? So for example, in Spring Boot, you should be able to depend on Spring Boot to be able to run through the init.sql or data.sql. And that would just be part of that Spring Boot data container. The Spring Boot data component. In which case you should be always being able to reestablish the same test cases that you expect. Otherwise, you will be testing against either stale data or data that somebody else changed.
Yeah, great. Yeah, that's good. Test containers, one of my friends, Rob Winch, he introduced me to that about 2 or 3 years ago now, and it's been really cool to see that tool grow in popularity, because like it just does exactly what you want, and it solves like a really important issue, kind of like, oh, you want to actually test against a Postgres database, but you don't want to have like your test data go missing or whatever it might be, or the database to be down when you run your test. So
exactly.
Anybody when watching, like, definitely consider using test containers for your integration test. It'll definitely help a lot. So I think we're at time, that we also have a break after this. So if there's anything else you want to maybe touch on, we do have a couple more minutes if you want, or we can just go ahead and end it here.
I just want to say thank you again for hosting it, and thanks all the organizers for putting this together. It's really impressive what everyone has accomplished so far. Yeah.
All right, thank you, Ray. And also make sure to consider buying a ticket to help donate. I believe the funds are going to WHO. And obviously the reason we're having this is because of the COVID pandemic, and donating to WHO can also help with resolving or help maybe mitigate some of the problems with COVID-19, or maybe hopefully actually work on getting a cure out there or vaccine out here pretty soon as well. So, all right. Thank you very much, Ray, and thank you everyone else. And I think we're going on like I said, about a